Hi, my name is Dana, and I will be going over question 1, Centerfold for the CSM 61B Week 5 worksheet. So this question talks about int lists. So before I start the problem, I'm just going to give a quick overview of the structure of an int list. So int lists are made up of int list nodes, and each int list node has a val and next component, and sometimes the val component can also be called item, and this contains the value of an integer, so 5, 7, and 3, and this would make the int list 5, 7, 3. And the next pointer points to the next int list node, and once you reach the end of the int list, the next pointer will be null. And if you want to refer to the entire int list, you can create a new variable, and that pointer will point to the int list. So can we get started with the actual question? It's asking us to implement center, which returns the middle node of an int list. And if there are an even number of nodes, return the one to the right. So the first approach that you might be thinking of when trying to solve this question is finding the size of the int list and then using that size to find the middle of the int list. But this would require us to go through the int list 2 times. So in order to create a better solution that would be able to find the middle without going through it twice, we can use a method where we have 2 different pointers, a slow pointer and a fast pointer. And we can use these to keep track of where we are in the int list as we're going through it in, for example, a while loop. So we know that our method takes in int list head. So this pointer will point to the int list. And for an example, we can look at this int list, which is 329. So what we want to do with these slow and fast pointers is we want to first set them to head. So after that, we want to have the slow pointer reach the middle node by the time that we're done going through our method. And we want to use the fast pointer to keep track of when we reach the end of the node. So in order to do that, we can have our slow pointer point to slow.next, which would allow it to point to the next int list node, and our fast pointer to point to fast.next.next. And then as you can see right now, our slow pointer has reached our middle node. So we would want to return the slow pointer, which means we want to be able to come up with a way to exit the while loop. So what we can do is when the fast dot next equals null, we can exit the while loop, and that will work when our int list has an odd number. But we can also account for when our int list has an even number of nodes. And for that, we would want to have the case fast dot when fast equals null. So we have our two checks for when we want to exit the while loop and how we are using our pointers. Then we would return our slow pointer because that has reached our middle node. And just to show how this method work when we have an even number of nodes, we can just look at the same example except now the int list is 3297. So we haven't reached the right of the two middle nodes yet. So we would still, in the next iteration of the while loop, have the slow pointer point to slow down next, which would be this node, and our fast pointer would point to fast dot next dot next. So it would actually point to null. And so that's why we have this condition here for even and this condition here for odd. Okay, so moving on to question 1.2. We can read the question, and it wants us to implement fold, which folds the first half of an int list over its second half, merging the intersecting nodes by summing their values. So if we look at an example that they have given us for the linked list 3, 1, 2, 4, the first half 3, 1 folds over the second half 3, 4, which results in the linked list 3, 7. So if we were to fold it over 1 and 2, the sum is 3, and 3 plus 4, the sum is 7. And then if we look at an example with an odd number of nodes, then the hinge is on the second node too. So when we fold it over, the 2 will remain the same, but we can add 1 and 3 to get 4. So if we look at the code that they've given us for this question, we see a few different things. We see that they want us to use this variable, which is an int list of result and returns result. And we see that they have given us an array deck DQ. So before we start the problem, I'm going to just go over the structure of an array deck. So over here, when we create an array deck and add elements to it, we can add elements from to the beginning using add first and to the end using add. And if we want to remove elements, we can use remove first, which will remove the first element and return it. So if we want to use that value that was in the array, we can use this and remove last. And then if we want to get the size of the array deck, we can use, we can call size. Okay, so now going back to the question, we notice that, again, we notice that result is a variable that they create in the beginning and it's what we want to return. So what we can do is think about what we did in the previous part of the question. So in the previous part, we created a center, which gives us the center of the int list. And if there's an even number of nodes, it'll give us the one to the right. So we can use that here and set result equal to the center of head. So result would, in this example, point to 2. And then now that we have our array deck, what we can do is insert all of the elements of our linked list into the array deck. So in order to do that, we can create a pointer variable and call it cur. And we can first set it equal to head. And then we want to add all of the elements of the linked list into our deck. So in order to do that, we can start with cur, and then we can add, use the add method and insert the first pointer in. And then we can go to cur.next. And insert the second element. And this is pointing to the entire node. And then we can continue. Until we want to stop when we've reached all the elements, and we've gone through all the elements in the int list. So that would be when cur is equal to null. So we would continue in the while loop while cur is not equal to null. Okay, I'm just going to get rid of these arrows so that we have a little bit of a cleaner workspace to use when we're going on to the next part. And then just redraw these ones. Okay, so now we have our array deck and it has all of the elements of our original linked list. We can try to see how we can modify the linked list so that we'll get the result that we want. So for 3124, we want to get to 37. And since our result is pointing to the center, we want to modify the values in these nodes so that they're equal to 3 and 7. So in order to do that, we can create a left variable and a right variable, and these will be pointers, and we can use these to modify our values. So we can also notice what methods that we can use that we have available to us. So for left, we can set it equal to our array deck variable dq dot remove first. So what that would do is it would remove this element, and then we would have this point to this this node. And then similarly, we can remove last and have it point to right. And then now we want to change the value in here. So we can set right.val equal to or plus equal to left.val. So then this will become 3 plus 4, 7. And then now we can check the size of our array deck, and the size is now 2, which is still greater than 1. So we can continue in the while loop. So again, left is equal to dq.remove first. So we can again remove this and set this pointer to where the new first element was pointing to, which is over here. And similarly, we can do the same thing for right when we remove last. And now we want to set right.val plus equal to left.val. So that's 2 plus 1 equals 3. And now our array deck is empty, and we know that because the size is 0, so the size is no longer greater than 1. So we can exit the while loop, and if we notice our result variable is pointing to this node, so this linked list, and it now has the values that we want. It has 3 and 7, which is the values that we wanted to achieve after folding. And then we can return result. Okay, and just to make sure that our code works for odd number list, we can just go through the example again with 1, 2, 3. So here we set result equal to center, and then I'm going to skip the step where we fill in the deck and just put in these pointers and go through the second while loop. So left is remove first, so we set this equal to the first element, then right is remove last, so we set this equal to the last element. And then right.val is plus equals left.val, so 3 plus 1 equals 4. Now the size of our array deck is 1, which is not greater than 1, so we can exit our while loop. And if we notice our result variable, it is pointing to 2 and 4, which is the final folded linked list that we wanted to achieve. And yeah, so that is question 1 on the week 5 worksheet.